But pleasure to meet you all. I will also unfortunately have to present in English because I only speak a little bit of French, but I'm going to practice as much as I can over the next few days in Guadeloupe. My name is Caspar, and I'm one of the founders and the CEO of a startup called AminoChain. Basically, Kiriki would have touched a lot upon this already within her presentation, but one of the biggest issues with scientific research today, or human subjects scientific research, is that we have a very high level of mistrust and a lot of a big lack of transparency for how samples are used within research. So today, the experience that exists for a patient that donates a biopsy sample or a saliva sample is a one-way street, right? So somebody goes to the patient and they say, can we keep your biopsy sample for a scientific research study? Here's a consent document. Do you say yes or no? When they sign that document, they give the sample in one direction to this industry of pharmaceutical companies, scientists, and researchers. And they create a lot of scientific insights and a lot of monetary upside, a lot of valorization of samples. And none of that ever goes back to the person that donated the sample. And that's a big issue because we end up having consent rates as low as 25%. So in New York, especially heterogeneous populations, only a quarter of people consent into research. And on average, we have around 84% of the samples consented into research right now coming from people of Caucasian, or better said, European background, right? And so that is an incredibly big issue. Trying to increase these consent rates and increase sample diversity is the biggest bottleneck in achieving precision medicine at scale. The second thing is that these samples are taken from patients, they're used in studies, and they're stored in biobanks. And so you guys got the phenomenal biobank over here, and so you all know what biobanks are, but effectively biobanks are really big fridges. They store biological samples and they use them within scientific studies. They operate at this intersection of research, clinical care, and informatics. And they've been growing exponentially from the 90s until today. So biobanks are phenomenal resources for scientific research. They're affiliated with hospitals, government labs, nonprofit centers, pharma companies, all sorts. In the United States, there's around 2,500 biobanks with around 200 million retrospectively banked tissue samples, up to $50 billion worth of scientific material. It's locked up across all these biobanks. And on average, a biobank only uses around 10% of the samples that they have stored. That's actually quite a generous number. Some collections use far less than that. We went around to 100 different biobanks. We asked all of them, why don't you use your samples more? What's holding you back? And they came back with two main reasons. The first was that they said we're scientists, we're not business people. So from our perspective, we raise a grant, we build the fridge, we collect samples, and then when we have samples in the fridge, we go back to doing research. And we don't think about the access policy, the distribution model, cost recovery mechanism of this biobank. And so poor business planning is the number one reason why biobanks are unsustainable. And then the second thing is that everybody said the process in which you acquire and license samples between each other takes very long. It can take up to 2 months right now. So if I want to find a sample, I would spend 2 months looking for it. When I find it, I'm going to email back and forth with somebody for many weeks, and then we sign a document and then they ship the sample. So the kind of picture that we end up with is that there's all of these hundreds of millions of samples around the world. They're super valuable research assets, but nobody knows who has what collections where. They're impossible to find, and even if you do find the thing, it takes you up to 2 months to actually acquire and license it. And so there's very poor infrastructure for moving research assets between biobanks and people that need them in their preclinical studies. So what we're building is a decentralized biobanking network. And how it works is every biobank installs this one software package called the node software. Every other biobank that runs the same node software is connected to each other in this decentralized network. Now, the rules of the node software are totally customizable. So you could put that into specifications saying that across all the labs within Guadeloupe, Martinique, and Guyana, we make our collections open to each other, but nobody else can see them. You could make it visible to only one other lab in Paris, and only the people in Paris can see how samples are being collected here in the French West Indies. That's just one example, right? But the same software could be customized for across the Caribbean, and then across North America, and then across biobanking consortiums like ISBO or BBMRM or whatever. So you can tailor the use case to sample visibility and distribution very, very granularly, down to exactly what your workflow is and who you collaborate. And this is ultimately what it looks like. See, you
have to change the sharing screen.
Cool. Oh, it's still. Stop sharing.
Yeah, go for it.
I see.
Press the X.
Yeah.
No.
Okay. Yeah.
Voila. Yeah. Okay. So this is what it looks like. You come to this platform as a scientist anywhere around the world, and you can look at all of the providers, all of the biobanks that have installed this node software. So this is our staging environment. This is where we demo stuff. But for example, you can come on now and see the profile pages of 2 different biobanks. But for instance, you could come on here and see the profile pages of all of the biobanks across a certain region within Europe, or you could see all of the connections within the carrier genetics network, for example, right? When you come onto here and you click onto any one of the profile pages of one of these biobanks, you could then see what kind of samples they have, what their accreditation is, and requests to see their full inventory. So this is just a high-level overview of like a profile page for a biobank. When you request and they give you permission to see everything, in the specimen center, you can then look through all biosample collections around the world at the same time in one place. And this is all based on the previous permissions that people have customized. So here, I'm going to type for globes, for example. All of the samples that are returned are live updates of the bio inventories of all these different collections. So if you click on any one of these samples, the data that you get about the biospecimen is updated every minute relative to how the biosample is used at that biobank. So if you use it here you create aliquots and derivatives, you create multi-omic data sets, it's all wrapped together into one view here for your network of collaborators, regardless if you store that across different databases or you use it in different protocols. And then from here, you'd be able to add the sample to your cart. And it's a kind of Amazon type experience where you can request additional services. You can say you want to have imaging done, or sequencing, or staining, or cold ice storage, or shipping. And then once you've requested that, it takes you straight into a licensing page. On the licensing page, you can already have a licensing template attached to the sample. So, for example, somebody could say, the biobank affiliated with the Pasteur Institute, make our collection open to all other collections in the Pasteur network. And then anybody could log on, they could request a sample, and it would be licensed straight away because they're within the same network. In other instances, you could have something like this, where you upload the licensing template, you can speak with the corresponding tech transfer officer, and you can redline clauses on the agreement, and then you can sign and execute all of it within the same platform. So the idea is basically you have one system to see all of the samples around the world, to get all of the data that you need about those biosamples, and then be able to acquire and license and pay for them in the same user experience. And so that's the idea that we want. The best part of all of this is we haven't even mentioned how this whole system operates yet with the technology on the back end, is that the patient that donates their sample is able to track where it goes throughout the network. So a patient that would have donated a specimen to any biobank, they would be able to log on and see something like this. They've donated 4 times in the past. they get the high-level overview of what's going on with all the samples that they donated. So, for example, 4 samples, how many studies ongoing, how many lives impacted. And then if they click on any one of the samples, they can see where exactly it is and how it's being used within scientific research. So this is the basics of it, right? We can build a lot of extra features on top of the system. For example, it's a contentious topic, but we would be able to allow royalty payments to go back to the people that donate the samples. We would be able to let the patients personalize consent for broad use. We would let them opt out, so you can be GDPR compliant, they can cancel at any point, and then everything that's tracked is canceled. You would let them, even though the samples are de-identified, you let them be eligible for clinical trial enrollment. So you'd be working with a de-identified sample in the lab, and you find out something interesting, you push one button and you can either return information, or you could let the patient know that they're eligible for a trial. And all of this can be done in a privacy-preserving manner at scale across many networks of biobanks. And so that's the high-level overview of AminoChain. We currently have a set number of biobanks that we're working with and currently onboarding roughly around 10 to 15. And we just recently closed our fundraising round, and so now we're at the point where we're just building and growing. So that's the high-level overview. I think I did it in like 10 minutes, so I got time for like 5 more minutes for questions. Good. Thank you.
You have to deal with ethics IRB for when you're requesting a sample or many sample from a country. You have to have the exporter of the sample need to have IRB.
Yes.
So how do you deal with this? I don't say it in your
in the workflow. In the United States, terrible regulation. It shouldn't exist.
We
But
know this,
Yeah.
know this.
yeah,
That's why it's very difficult to send sample to the United States, because we know that we don't have the same rules.
yeah, exactly. So in the United States alone, the federal regulations are that if you de-identify retrospective collections, then you don't have to reconsent for secondary research use, which is stupid. It makes no sense. But it basically means there's 200 million samples in America lying around and not being used. You could go to all those biobanks, you could de-identify them, and then put them onto a market and let people start to distribute them. At least they get used more. But that's just for retrospective collections, right? The step that we're really focusing on thereafter would be for prospective collection. And that would be where you have requests for new samples that come through, or for new insights or new research protocols. And you need to have IRB integrations for that, of course. So we've outlined our own framework for something that would work with a system like this. It's called demonstrated consent. We wrote a paper on it, and it was published in the American Journal of Bioethics. So that just recently came out. If you'd be interested, we'd love to send it to you. But basically, the idea is that we across our system get biobanks to adopt broad consent and let the patients track where their samples go, and let them opt out at any time.
To expand a little bit on your question, so when Caspar mentioned a procurer comes in and sees a series of biobanks in a network, and they put in a request. So we were just having this conversation with them, and we're working with FTD, so similar premise. The request button, behind that request button, can be a series of operational steps where they have to submit an SOP, they have to submit what their intention is for sample, that they submit their IRB approval for their study, and then that gets to you in a more streamlined way than what is done currently via email. And so you have a structured input of what the expectations are from a procurer, and you can match that yourselves to whatever requirements it fits within your ecosystem. And then, because this is modular, only demonstrate or make available those samples that you have determined meet those criteria based off of that process. So that's in addition to our more avant-garde applications that can be generated off of this infrastructure, like what Genetics are doing and some of the other partners that we're doing. We essentially meet institutions where they are and adapt to or make their processing, their operational processes, much more efficient in the terms of work being done on both ends.
Yeah, it's basically when you come to this view, And you see all of the different biobanks in the world over here. When you click on their profile page, whatever you want, you can customize.
Just another question, how do you connect? What do you use to connect?
Yes.
The biobank?
It's a great question.
Different biobanks, interconnection, because we use different software, different, how do you, how to connect them to your platform?
Great question. I need to share another, let me go back to the slides. So, this works, right? Yeah. Okay, so what we are doing basically is connecting these biobanks together with a blockchain protocol. And so that's how everything is harmonized and connected together, right? So right now, these biobanks use all sorts of different combinations of lab inventory management softwares, data capture softwares, EHRs, EMRs. Some don't have any type of recording system. They use Microsoft Excel. And they're all very different, right? What we do is we go to these biobanks, we tell them to install this node software. Now, the node software is something that they run locally on their servers. So it's like another local software. It integrates via APIs into the tech stack that they use, and it abstracts away a blockchain protocol. And a blockchain is just a shared database. So what's great is because wherever the samples go, we can use the blockchain to track the provenance. We can see the chain of custody of where the samples go, what data is created from it, and then we could use that to wrap back across networks. So it doesn't matter what you use locally. We can harmonize the picture of where samples go and how they're used by virtue of having the shared database in the back, which is the blockchain. We can talk about that like much longer as well, I'm sure. Like, because I probably just opened up a whole new thing. I can show you very quickly maybe one other thing. Not too easy to jump between the.
While he's transitioning, so only 40% of biobanks in the world have LIMS or BIMs. Many still run on Excel spreadsheets for their inventory, and some still leverage paper. We ingest those as well. So a static, so in the instance of a non-LIMS, it would be a static imaging. As a matter of fact, even for those who are interested in LIMS integration, you need to get the static picture of the inventory to be able to map and harmonize it to a global search schema. So we can do that, it just would remain static, as opposed to what Caspar is about to show now. There's a full integration into LIMS. We essentially read in real time. So as a new sample is updated and has been cleared for display to partners, it becomes there. And if it is removed, if it's purchased, removed, or the patient deconsents or removes their consent, then it drops off, and it drops off on the display as well.
Yeah. So if I understand correctly, the LIMS that you use in the biobank here is module bio. Is right, exactly. So it's module bio. This one is open specimen. You might have heard of it as well. It's like another type, like module bio. There's roughly 35 different LIMS vendors out there that are relevant for human sample biobanks, like Cloud LIMS and open specimen and module bio and so on. Regardless of whatever LIMS you use, you would be able to, this is how our node software would interact. You would come here as a scientist, and you could, for example, record the fact that somebody has just donated blood. So you'd say, we just got whole blood, and it's 200 milliliters, and it's non-malignant, taken from the abdomen, or whatever the details are. You can add a barcode, so you de-identify the sample, and then click save. And the node software scans for updates every minute. It sees that you stored a new sample, so now we pull that information and we mint a record on the blockchain. And so that's great, because what you're seeing on the marketplace later is not necessarily a LIMS recording, it's the record of what's on the blockchain. And that's important, because that means that it's the same for everybody else. And that's why you can really trust the information that you get, because everybody's reverting back to the blockchain, not to their private storages, right? So that's how it works.
Is this platform secure the cloud?
Yes, we don't move we don't move any of your data away from its local servers. It's the only thing that we hold with this blockchain is where does what go, this provenance. And then we only show that provenance to the people that are allowed to see it. Otherwise, everything stays exactly where it is. Yeah, we've written a couple more papers on the idea and the concept and the theory of the emerging technologies in biobanking. And so if and when they come out, we'd probably love to send them to you as well, because I think it's the most effective way to get people to understand it properly is when they can sit down and read it and see how it works. Yeah, thank you so much.